G'day guys excuse me. G'day guys and welcome back to my channel. Um, I just got a quick update for you. Like I said, I wasn't going to make another video until I'd got a bit of work done on this. Um, I've got about an hour and a half of video footage to upload of me just mumbling on and tracing stuff out on these boards and doing work on it. I might splice those videos together and upload it and just put in the title me rambling away and working on boards or something, so you don't watch it and waste your time. But with that being said, I ended up deciding to just go the full yard, 9 yards, or whatever the saying is on this. I've traced everything up. I've also replaced all of the resistors with carbon style ones for lower inductance and higher power dissipation than what was there. I did note that on the bottom side of the board I found odd value resistors. Someone had actually put the wrong value resistor there and there. So I ended up replacing them all with just even brand new ones. I did what I said I was going to do here too. The 1 ohm resistors and the 0.47 ohm emitter resistors. And if you have a look at this connector here, I've traced out all the feedback paths and where they go to in terms of board-to-board interconnects. So the next, and I've also decided I'm going to put a couple of base resistors in there. Something small, less than 10 ohms, maybe 4.7 ohms, maybe 2.2 ohms. But I'm going to add some base resistors in there. I'm talking about on the actual series pass elements. There was something else. Oh yeah, so after I replaced all the resistors, and I'm not just talking about these power resistors on top, but the ones that were on the bottom of this board that were incorrect values, the dual tracking now, it worked before, but now it works to the millivolt. I mean, like if you set one channel at 5.00 or 5.01 and set the scale, the tracking ratio knob on the slave to the same, when you turn it up, it tracks perfectly. Before, it tracked almost perfectly, but it would be off by like 100, 200 millivolts. The more you got, the more it would go out. Now it tracks perfectly. So I'm glad that I found that. What else have I got to say? I guess that's really it. I have not yet powered it up to see if it's still oscillating the constant current. When the voltage is down low, it sort of oscillates. I haven't tested to see if that's gone away with these different resistors that I put in there. Probably still does. Maybe a little bit better, but it probably still does. That's something I'll dig into after. Like, I haven't even pulled the oscilloscope yet out for this. So far we're looking at DC characteristics and component values and stuff like that. Put it so, we've got one more thing to track down. Why the slave supply turns up to 54 volts with no regulation. It's essentially like an unregulated supply, but when you put it in dual tracking mode, it works. We've got to solve that problem. As soon as that problem's solved, the scope will be coming out. We'll be looking at the outputs and the inputs of all the different op amps, and anything that's got noise on it or ringing or whatever, we'll fix that up, and transistors too. We'll be looking at all the semiconductors in the circuit basically, other than the diodes. So that's all I've really got to tell you guys in this video. It's just a quick update. Like I said, I've gotten about an hour and a half of footage whilst I was changing, those resistors, making up. This was 1.8k resistor and this was a 2.2. I had a 5 watt 2.2, but I didn't have a 1.8, so I just got 4 1.8s and put 2 in parallel with 2 in parallel in series to make a 4 watt 1.8k resistor. I was just doing a bit of talking and measuring and tracing stuff out, all that good stuff, you know. And yeah, so I might upload that, but like I said, I'll just put it as me doing board work or something like that, so people don't get bored on it. With that being said, that I'm going to leave this video off here. The only thing I haven't done yet, like I said, is base resistors. I want to add base resistors because the base is on the two transistors on the back on each channel. The bases are just tied together with a bit of wire. The only balancing they've got is the emitter resistors. So I want to do something about that. I don't like that. Especially when one transistor's above the other one, which means it's going to get hotter because heat rises. You know, that means the top one's always going to try and share more current than the bottom one, even if they're perfectly matched. So, emitter resistors, base resistors. Might also have a look into something else that I noticed was that these resistors here are the base to emitter resistors for the outputs. They're 10 kilo ohms. I find that a bit high. In all the supplies I've worked on and built, it's been more in the realm of 100 ohms to a kilo ohm. I've seen some Chinese supplies that have got 10k resistors basically everywhere, but the Chinese don't do math, they just put shit anywhere. In everything that I've designed myself, I've actually done the math for, and in everything that I've pulled apart, I've usually found it's going to be around 100 to a kilo ohm, 100 ohms to a kilo ohm. So, I don't know, it makes me wonder, because there's a lot of resistors that have been replaced in here, and you know, like these ones are all 4.7k. That may be what they're supposed to be, you know. 10k for the base to emitter resistors. I'm talking for the series pass element, like the actual outputs. That seems a bit high, so basically the next video I make, we're gonna put this back together and start testing. And basically what I've come up with, the idea I've come up with, is to basically, the way it works is the pot you set the voltage on, it has the same voltage on it that's what's on the output. However, it's not, you know, like in parallel with the output or attached to a resistor divider or whatever. So what it is it's basically the reference that an op amp sets the output to, so to speak. If we can trace back, you know, turn that up to say a specific voltage like 25.6 and then go test around the board everywhere, we already know where the feedback paths are for everything. I'll explain all this in another video. We should be able to trace back and see where that high voltage is originating from and what's supposed to limit it at the 30 volts. And we should then be able to fix that problem, which means then we're just left to compensating op amps and putting it back together. Base to emitter resistors. Honestly, something else I'm tempted to do is take the BC107s out and replace them with BC550s, and look up these are 2N2270s and these are 2N435 4s and 5.6. One's changed. Someone's changed one of them. It's just a 20 volt high part. It's the same part. I might find better transistors. Even the driver transistors, I find it funny driving 3F55s with big 3F55s. I've got way small transistors that can drive those 3F55s on the back without needing to be that big. And I can keep those. They're probably nicely matched. I can keep those for something else. So this thing might get better transistors, but yeah, there's a few things coming up. I'll just quickly go over this, just 2 seconds. So basically, it's all labeled on here. That's your negative and positive feedback for the master channel. That's your negative and positive feedback for the slave channel. when you put it in auto tracking, these two pins get joined together. Also, when it's in auto tracking, this pin here becomes the voltage on the pot from the master, the positive voltage on the pot from the master side. It's not linked to these two, it just becomes that. I've also noticed that this pin is the voltage on the pot for the slave negative, voltage on the pots, voltage pot slave negative is what anyway. VPM negative, VPM positive, VPS negative, VPS positive. So I've worked out where all the feedback paths go, is what I'm trying to get at there. So I feel pretty confident the next video we're going to have this thing solved, because well, all we got to do is work out where that higher voltage is coming from, what caps it, you know, reference going to a voltage divider, going to an op-amp input, whatever. Like, we need to just investigate what that is, where it is, and fix it. And then, like I said, compensate any op-amps and transistors that are ringing and put the thing back together, and we're done. So yeah, there you go, guys. Sorry it was a short video, but I just wanted to fill everyone in on what I've done so far without making a long ass video just to explain that. Alright guys, I'll see you in the next one. Thanks for watching.